In this demonstration, I'm going to create a size-on-size saddle and a size-on-size hole for that saddle to fit in. So the first thing I'll do is create a saddle, and this is just a regular saddle, and here is a size-on-size button that I pick, and it shows in the highlight the various fields that get overridden when I pick that. One of the fields is the mate pipe diameter, which automatically sets to the inner diameter of the pipe, because that's the intersection line between that and the mate hole. So it sets it to 9 inches in this case. And if I load the machine and make dynamic changes, that will dynamically change. So if I make a smaller, slightly smaller pipe or a different wall thickness, that will change with that so that it doesn't break this or it stays accurate. It also sets mate offset to 0 and root gap to 0. So at this point, the only thing left to do really is to mess with your bevel angle. You want it to be very wide because you're trying to open up a gap between the two mates. So in this case, you would say something like 70 to maybe 90. You'll see here that it's limiting out right through this flatter section right there. You can kind of see the little change right there where it starts to limit. If your torch will only go 45 degrees, then that's about as good as it's going to get when you mate the two pieces together. They're just going to be flush, and you might have to do a little more grinding if you're trying to create a fill gap in that. If your torch will go farther, if you're using gas or you have a high angled torch, then certainly you can benefit more from setting this higher. Setting this higher now will just mostly blow out this section, which isn't limiting at this point. So as I do that, you can see it shifts out a little. You can make that quite a bit bigger if you want. It just depends what you're after. In the second section of this tutorial, I'll talk a bit more about how this is affected in 2-axis machines. So now I'll make a size-on-size hole for this saddle to fit into. I'm just going to put it on the same pipe, even though you wouldn't do that. Put it on a separate pipe. So here it came in with a diameter of 2. It's at 0. I'm just going to move it over to, say, 12. And then I'll just pick size-on-size. And you can see it overrode a number of variables. It overrode the diameter and made that to the inner diameter of the pipe. It set root gap to 0. It set the cut surface to ID, and it set side offset to 0. So now what you have to mess with again is your bevel angle, and here we might say 70, and you can see it's limiting here and pushing out here. So if you make this 100, just get what you like for your fill gap. If you're limiting out here, you may need to grind out a little bit. In the picture I showed, the pipe had a mate 1 angle or a tilt or slope, depending on your language for it. So I'll show that as well. I'll just go ahead and give this a 30-degree angle. I can go 120 or I can go 60. It depends on the orientation of the rest of the part. Here I'll go 60, and I'll just bring it around so we can look at it a little better. So you can see this piece would, if I picked it up, flipped it over, would connect into that. So now I'm going to discuss 2-axis machines, because the 2-axis machine cannot do this. It has to set the torch this way, which means this cut would be angled that way as well. And so let's just look at that. I set my gas torch to be 2-axis so I can demonstrate this. And look at that. We've got just a real crazy looking thing going on here. So I'll take my bevel angle and I'll move this back to 0. And now it looks pretty normal. The problem is now you have to grind out this whole edge and this whole edge to match what it looked like when you had plasma. Okay, so that's the shape you're trying to get to, and this is the shape you're going to get if you want things to come out really nice in the corner. Now there are some options. You could go with a bevel angle, say, of 55 or 60, and that will give you this side quite good, and then you could just go and grind out this side, staying along the inside line, preserving the inside line, because that's correct. You will wind up with some strangeness down in the corner if you do it this way. And one other thing you can do if you're really adventurous and don't mind filling a lot and grinding in the corners and saving yourself a bunch of time grinding over the top, I can duplicate this cut and just set the second cut to a negative bevel angle. Okay, there's a lot of problems with this, which is fixed in 4-axis. I'm just trying to be helpful here. But if you do this with the plasma torch, you'll wind up skipping through this section on the second cut, which may, if you have skip mode, you can turn that off. You may ruin your consumables doing that, and you may also arc into your part. But if you did it with gas, you might be able to pull this off. You'll still wind up with a cut into here and a cut into there and a divot right there. But they will join right in the corners. You see on the far side, they'll give you a nice corner on the inside. You just wind up filling a lot. So that's the extreme story for trying to do it with less grinding. Go back to the way it probably should be done, that way. Now, for this in 2-axis, there's really not a lot to do. Your bevel angle will have to be reduced a bit. So looking at that, that gives you a nice bevel angle here, but you do wind up, because it's fixed, it doesn't start to taper off here, you wind up with a pretty big gap here that if you placed in here, you're going to wind up filling a lot. So you may want to look for a compromise between not having to grind up here and not having to fill there. So if I went something like 45, I would have this nicely done. My inner edge is still true, and I could just grind back off of this to get some fill space for this.